ECM motor technology has definitely been around for over 20 years. Gone are the days when you had to select speeds by variable sheaves and belt drives. Today, all they got to do is just plug in the motor correctly and select your speed by the way the motor is wired. This type of motor is used extensively throughout the residential HVAC industry in supply fan applications. That means setting up a residential HVAC application is almost plug and play. The motor has a little integral microprocessor built into the back of the motor. This microprocessor converts the incoming AC signal to DC and then back into AC again to actually run the motor. As usual with all the advantages that comes with technology, the catch is that these ECM modules don't last that long, sometimes as short as 6 years or so. Up until fairly recently, you usually could buy just the electronic module if the motor itself was okay. But now, not anymore. You got to buy the complete motor. I discovered mine was bad by the fact that I was getting no airflow inside the house. And when I went outside, the unit itself was making ice around all the refrigeration piping, indicating no airflow. I had already placed one module in my other AC unit several years ago, so I was kind of surprised that I could no longer buy a replacement module. I started looking around for motors and found out they were rather expensive at $500 in some cases. Shortly after that shocker, that's when I ran across Evergreen. This particular ECM-Genteq motor proved to be a direct replacement for mine. Half horsepower, 208, 230 volts, 4.1 amps, belly band mounting, and 24 volt AC control. The motor I'm showing here is actually my old motor. The only difference between the old motor and the Evergreen motor is the Evergreen motor is green and the shaft length is about 1 inch longer. According to the manual that comes with the motor, it supports 24 volt AC control, 18 volts DC control, and pulse width modulation control. The motor also comes with a connector that allows you to convert an older motor wiring harness to this newer motor wiring harness. Most units come with a general service wiring diagram somewhere attached to the unit. In my particular case, it was behind the compressor door. Since this is an after-the-fact video, I'm not going to get into the actual removing and replacing the motor. There are other videos out there that do cover that. I'm primarily looking at the wiring in this video. In my particular case, the motor runs on 24 volt AC control, and I have a choice of 5 speeds depending on which connector I plug into the control board. The orange wire is the medium-high wire. The brown wire in this case is the neutral. The multi-conductor black wire in this case is for supplemental electric heat. The 2-conductor black and white wire that is orange jacketed is the wire for the actual unit itself. What I'm doing here is just making sure that at this plug-in I'm not exceeding my 4.1 amps. As you can see, I'm at 2.76. I've got plenty of tolerance left. Here's my clamp-on ammeter set up. In this particular case, the clamp-on ammeter is a supplement that can be bought separately that works with my fluke meter. Here's a listing of all the available ECM motors available from Evergreen. These motors are intended as direct replacements for earlier generation ECM motors, and they're about half the cost of a new motor from an authorized manufacturer replacing with the direct factory motor. Well, that wraps this one up. If you like what you're seeing, give me a like and consider subscribing. Just might have something else coming down here real soon you're going to want to see. Till then, take care. Hope to see you on the next video.